Hey party people. So you are likely working on assignment number 1, finding where two moving objects collide that are two toy cars that are moving in the hallway. This video is not intended to help you solve that problem. This video is intended to help remind you how to represent what a motion map is, what a position time graph is, what a mathematical representation of that motion is. So with that in mind, I'm going to just start with an image. You'll have to solve the problem using your own problem-solving strategies, whatever those may be. Here, let's just say that the track starts at position 0 meters, and it goes up, all the way down the end of the hallway. I'm going to estimate it to be 25 meters. All right. There'll be a little toy car that starts in front of my room, which is 6 meters away from the beginning of the hallway. That toy car moves with a certain velocity, v. Let's suppose that velocity is, 25 centimeters per second. A motion map, what a motion map does is it puts the whole position here. So it goes from 0 all the way to 25 meters, if that's the important part that we're talking about. And you just put a dot where the object starts, an arrow showing how much farther it goes each unit of time. In this case, it might likely make sense to do 1 second, since you know how far it goes in 1 second. Now notice it doesn't go 25 meters in 1 second, it goes 25 centimeters. You might have to do a conversion. Okay, this thing is always going the same distance, so the length of those arrows is always the same. All right, let's do another one. Position time graph. Here we go. X means position, T means time. The units are going to be seconds. And I could choose either, but I'm going to go with centimeters for my units here. All right, so it starts at 6. It's going to be moving in the positive direction, so it'll take some amount of time. I don't know how much time, but it's going to end up at 25 meters. Oops. So if that's centimeters, that would be 600 centimeters, is 6 meters. And then this would be 2,500 centimeters. All right. And then finally, since this is a straight line, we can model straight lines in the form y equals mx plus b, if you remember. In this case, however, y and x are our variables. The y variable is position, so I'm going to put x. The x variable is time, so I'm going to put t. The slope of this graph is how fast it's going. It would be 25 centimeters per second. So that's m plus where it started, which is 600 centimeters. All right? Here would be a mathematical representation of the motion. Now, use those representations to model the motion of both cars, and then answer the question, where do both of those cars collide? Where and when? Find the time. Solve it graphically, solve it diagrammatically with the motion map, solve it algebraically with your equations. However you need to solve it, find a way to do that. Good luck.